Hi everyone. Today's class is about programming and debugging of handling industrial robot. The contents of today include the following: the moving of packing boxes and robot palletizing. Task description. Robots are used in industrial production for handling of objects, both in the horizontal position and in the three-dimensional position. The task in this section is to move a packing box from an assembly line to a transfer vehicle for warehousing. Workflow and application program writing. The packing box has a certain degree of flexibility, so the gripper is required to have moderate strength to ensure that the workpiece does not fall after clamping. And the force of the gripper needs to be large enough to ensure that the pressure is not too small and generate enough friction to ensure that workpiece is gripped. In the process of writing the program, it is important to avoid robot collision and action adjustment. The workflow is starting, robot waiting at home position, starting conveyor belt. Sensors determine if an object is detected. Conveyor stops. Robot moves to the top of the gripping point. Suction cups pick up material fast. Robot moves to the top of the gripping point. Robot moves to above the placing point. Robot moves to placement point. Placing object. Robot moves to the top of the placement point. Robot returns to home position. End. Demonstrate to the robot P-pick, P-place base, and P-home, as well as several other key positions, accomplished by combining instructions such as move L, move J, and move C. Programming of the robot is easily accomplished. Programming the robot requires to create the conveyor belt start signal DO39, control of conveyor belt start or stop, conveyor belt end sensor signal DI6, detector of the end of the conveyor belt, whether there is material, suction cup signal DO36, and control of suction cup operation. During the programming process, it needs 3 points to be shown: P-home, P-pick, P-place. In pick and place, to save programming time, it is supposed to use offset instruction, set and reset. For suction cup signals, wait DI is used for waiting for sensor signal. With this command, the waiting time should be continued and the moving speed should be V200. By applying to data D 吸盘, program debugging and related notes. The correct operation of the gripper is to move directly above the box and then slowly descend to grasp the box vertically. The size of the gripping force should be determined according to the weight of the box and the amount of external force based on need. When programming the robot, the use of move L, move J, move C, and other instructions should be selected according to the path characteristics. Robot palletizing. Task description. The widespread use of three-dimensional warehouses in modern industrial production has objectively promoted the popularization of palletizing robots. Palletizing is a type of handling from its nature. Path planning should be performed in advance for the robot, and then the object is moved from one position to another according to the path. The difference lies in the two handling positions. In this task, a palletizing task with 6 rows and 3 columns. Columns should be operated as shown in the figure on the right. Workflow and application program writing. Workflow. First, start the conveyor. The object moves along the belt. When it reaches the end of the belt, the conveyor stops, and the robot suction cups start grabbing the material block to lift to a certain height. Next, is to place on a designated position. The distance between the object should be 140 millimeters. The number of objects to be placed is 6. If the task above wants to be completed, there should have 2 steps. First of all, the robot gripper needs to be able to grasp the workpiece smoothly. Care needs to be taken to ensure that firstly, the pneumatic gripper is able to generate enough force to grasp the workpiece. And secondly, the force of the pneumatic gripper must make sure that it causes no damage to the workpiece. Both of these issues can be adjusted by the values returned by the mechanical sensors. On the premise of not damaging the workpiece, in operation, the next step is to plan the robot path. When selecting the robot trajectory and operation method, the method of using demonstration point is adopted. Some key points are set on the robot's trajectory, and the robot's trajectory can be roughly determined through the setting of these key points. In the programming process, a structured program design method is used to divide the program into several subroutines. This saves programming time and makes program reading faster. The workflow includes conveyor belt, start signal DO39, control of conveyor belt start or stop, conveyor belt end sensor signal DI6, detecting the end of the conveyor belt whether there is material at the end of the conveyor. Suction cup signal DO36, control of suction cup operation. In programming processes, there should be noted that 3 demonstration points are included: P-home, P-pick, P-place. In pick and place, and in order to save programming time, use the OFF instruction set and reset to reset the suction cup signals. Wait DI is used for waiting for sensor signal. The waiting time should be continued, and the moving speed should be V200. By applying to data D 吸盘, setting one bowl data type B ballot full is used to determine whether or not to continue palletizing. Set one num data type for counting the palletized data. Here is the palletizing workflow. Start. Robot startup. Robot home position detection. Pneumatic gripper release detection. Robot moves to the table. Robot moves to workpiece to be gripped. Pneumatic gripper closes. Transportation of the workpiece to the warehouse. Pneumatic gripper released. Robot returns to home position. Determine if 6 routes and 3 levels are completed, a total of 18 workflows. They end. Program debugging and related notes. In order to minimize the impact, reducing the running speed of the arm as much as possible during the process of gripping the workpiece. And in the preset path, a few more points will enhance the controllability of the path. When using the gripper, make sure that the robot arm rises vertically. The displacement operation in the vertical direction Z can be accomplished by using the OFF instruction. For the stability and safety of the robot, the program should try to avoid tilting movements. If the movement needs to be adjusted during operation, it should be adjusted while moving on the running program. When the robot leaves the work area, speed up the robot movement. Minimize the ineffective working time as much as possible to make the operation of the robot more efficient. Okay, that's the end of the class. Thanks for watching.